So let's continue the story on this cross bridge cycling. So what is the role of calcium in this entire thing? So calcium's role of calcium. So this is what calcium does. So let's assume here, so here you have your actin molecules hanging out. And again, remember that they have a binding site for myosin on them. And that binding site is covered by your tropomyosin. And so here you have your troponin molecules are here like this. Remember, their job is to bind to calcium. So let's say here, your situation here where there's no calcium, or you have low levels of calcium. In this case, the tropomyosin, even though it's ready and cocked and wants to bind, it cannot bind. No cross bridge is there because the myosin can't bind because the tropomyosin is blocking it from binding to it. Okay, I probably be using the wrong term altogether. This is myosin, not tropomyosin. So here's myosin trying to grab, and it cannot grab because it's being blocked by your tropomyosin. That's what happens when you have no calcium. When you have calcium around, so with calcium, it changes a little bit. So here you have your, again, actin molecules. Actin molecules there. And now your troponin can bind to calcium. So now Ca is attached to it. And when the calcium is attached to the troponin, troponin will grab tropomyosin and put it out of the way, pull it up like this to then unblock actin. And therefore, your myosin here can now grab and form a cross bridge. So cross bridge forms in the presence of calcium. And whenever you relax, the reason why you can relax is that there's no calcium there. And even though you want to grab and pull, you can't do it because you're covering the binding sites on actin. So that's the role of calcium. It allows for you to cross bridge cycle by exposing actin to myosin. Okay. Another feature of this process is other properties. Other properties. One, each head of myosin, remember these myosin have many heads on them. So each head of myosin can cycle, meaning it can cock, grab, pull, detach. It can cycle 5 times per second. So in 1 second, it's done the entire thing 5 times. Okay, it's very fast. So that's why you can't really perceive it. It's rapid. Also, each head can cycle out of sync. Each head cycles what's called asynchronously. Meaning, if this is your, say, myosin bundle, some heads may be here, some heads may be doing this, some heads may be doing this. It's not all in sync. They can be in different stages of the cross bridge cycling. So that way it's imperceptible. Because if they all would pull and detach at the same time, then the muscle will return back to its length like this. So they're all in different stages of the process. So that's called moving asynchronously out of sync with each other. And thirdly, each cycle requires 1 ATP molecule. So 1 ATP molecule happens per cycle. This is why you get tired when you move your muscles, because each head requires 1 ATP molecule to bind to it to perform a cycle, and each head can do it 5 times per second. It's a lot of burning of ATP that's being used in the process of moving the head. Okay, well, this ends our lecture. Well, no, we'll pause here again.